Hello and welcome to my channel. My name is Dr. Moazam Javed. I have done my PhD from City University London and my postdoc from University of Lincoln, UK. My area of expertise, this is image processing or simply digital image processing, because whenever we are employing computer for handling images, this basically becomes digital image processing. Moreover, specifically, I have been working with medical images, including all type of medical modalities, MRI, CT, X-ray, and other imaging methods as well. This a particular playlist. It will cover the contents normally taught at bachelor's and master's level in undergraduate courses, normally sometimes at postgraduate, and the content will cover the routine topic specifically related to image processing, including like how can we define an image, how images are defined, and by default images are analog in nature, what mathematical operations are normally carried out in order to convert analog images into digital version. So after covering the basics of image and after developing a suitable mathematical model of an image for representation in computer, we will start talking about imaging geometry. Because we do have a lot of different operations, we do have a lot of different mathematical operations which are normally we do carry out using different end user products, different end user tools for handling manipulating images. However, in the backend, all those operations are being carried out in terms of some mathematical operation, some geometrical transformations. We will explore all those possible mathematical operations, including different transformations, including scaling, rotation, zoom in, zoom out, that is basically scaling, rotation, displacement, and perspective transformation. That is how 3D objects and how 3D scene, how 3D world is mapped on a 2D screen. How three-dimensional objects from the real world, these are mapped on a 2D screen. Normally, this is what we call as, what we define technically as perspective transformation. This will be followed with the functioning or mathematical representation of camera, and how camera converts or how camera acquires images from 3D and how it does do transformation on 2D screen. Once images have been acquired, the next step is normally to improve the image quality, because the actual acquired image, because of any reason, because of a malfunction of devices, because of light issues, because of any reason, the acquired image, it might not be very suitable for processing in context of a particular job. Therefore, a sort of pre-processing or image enhancement is performed, and this image enhancement, it again covers a lot of mathematical operations, including sharpening and smoothing. Many times, depending upon the problem identified in the input image, we might want to smooth the present noise, or maybe many times we might want to make image sharper in order to make it more comprehensive and attractive. So we'll talk a lot about image enhancement, mathematics behind image enhancement, and image filtration. This will be followed with image segmentation. Normally, segmentation refers to breaking down an image into multiple individual components. Maybe individual objects are to be identified, maybe individual objects are to be accessed, individual objects are to be tracked and to be processed. These can be done either using conventional gradient level, that is basically change in behavior, gradient approach, or we can use region based segmentation. In gradient based methods, we normally identify the points where there is significant intensity change, normally lines or edges, whereas region based segmentation, we keep on merging different pixels on the basis of similarity in their behavior. This will be followed with bit plane slicing and image steganography. Normally, it is like industry, we do use this steganography, that is hiding data in images. Steganography represents a very good mathematical approach for hiding some important data inside images such that your end users will not be able to notice, they will not be able to read what is hidden until and unless a decoding key is provided. Similar to encryption, decryption, data hiding inside images is what normally we call this as steganography, and we will talk how this is implemented in images. And finally, the object detection and quantification. This again will be very important, and we'll see how object detection on the basis of maybe certain patterns, on the basis of maybe some structural pattern, on the basis of maybe some intensity or their appearance, we detect different objects, and accordingly we might be interested to perform the quantification. Quantification normally refers to a like particular object's area, minor axis or major axis length, area, surface occupied, and this becomes very important when we work in context of medical images, because it is like a first option for clinical analysis to diagnose and quantify the damage caused by any problem, damage caused by fracture, damage caused by tumor, either in X-ray images or CT images. So quantification is more like it is extremely important in medical imaging especially. So in context of like reference, we will be using the standard handbook of mathematics, standard handbook of image processing that comes from Rafael C. Gonzalez. Like basically we do have two resources from Gonzalez. One is like simple structural representation, classical image processing, and one is like equipped with MATLAB help. And along with this, we do have some alternate resources as well for reference, and maybe you'll find a number of different blogs as well. The good thing of this course is that along with every theoretical lecture, I will also provide a respective video, a corresponding video in which I will demonstrate all the concepts using MATLAB. I will demonstrate practically all the concepts using MATLAB so that end users can easily understand and comprehend the ideas. For every lecture, I will be uploading two videos, one with the theoretical concepts and second one with the practical implementation of whatever we have discussed in theory. And definitely we will keep using MATLAB because MATLAB allows us a lot of options for handling processing images. So please stay tuned, and I will keep uploading lectures one by one, and please you must refer both videos for theoretical concepts and its practical implementation in MATLAB. Thank you. Stay tuned.